Hello everyone and welcome to the AI Learning Podcast. I'm James, your host, and I'm so glad you've joined us today. In this podcast, we aim to break down the complex world of artificial intelligence and machine learning, making these topics easy to understand for everyone. Whether you're just starting to learn about AI or you're already deep into the subject, we'll cover the basics, explain key concepts, and explore how AI is transforming our world. I'm thrilled to be here with my insightful co-host Ethan, who brings a lot of expertise and energy to the conversation. Ethan, why don't you introduce yourself?
Thanks, James. Hi everyone, I'm Ethan, and I'm excited to be here on the AI Learning Podcast. I've been passionate about technology and AI for years, and I'm looking forward to diving into today's topic with you all. Together, we'll break down machine learning in a way that's fun, easy to understand, and most importantly, accessible to everyone.
All right, let's start with the basics. So, what exactly is machine learning? In simple terms, machine learning is a type of artificial intelligence that allows computers to learn from data without being explicitly programmed. Instead of giving the machine step-by-step instructions, we provide it with large amounts of data, and the machine learns patterns and relationships within that data. Over time, it improves its predictions or actions based on what it's learned. For example, if we feed it a lot of pictures of cats and dogs, the machine can eventually learn to identify new images as either a cat or a dog, just like how we learn by seeing patterns in the world around us.
Exactly, James. Now, you might be wondering how this differs from traditional programming. In traditional programming, we write code to explicitly tell the computer what to do. So, for example, if we wanted a program to sort numbers, we'd write out the exact steps to compare the numbers and put them in order. But with machine learning, we don't tell the machine exactly how to solve the problem. Instead, we provide data and let the system learn the rules for itself. It's like teaching a child to recognize animals by showing them thousands of pictures rather than giving them a rule book. The more data the machine sees, the better it gets at making accurate predictions or decisions.
James, now that we know what machine learning is, let's take a look at the three main types of machine learning. These are supervised learning, unsupervised learning, and reinforcement learning. Each of these types works differently, and they are suited to different types of problems. First, let's talk about supervised learning. In supervised learning, we teach the machine using labeled data. That means we provide the machine with input data along with the correct answers or labels. The machine uses these labels to learn the relationship between the inputs and the correct outputs. For example, if we wanted to teach a machine to recognize emails as either spam or not spam, we'd give it a set of emails that are already labeled as spam or not, and the machine would learn to classify new emails accordingly.
Exactly, James. Now, let's move on to unsupervised learning. In unsupervised learning, the machine is given data without labels, meaning it doesn't know the correct answers. Instead, the machine tries to find patterns or structures in the data on its own. This type of learning is often used for tasks like clustering or grouping similar items. A great example is customer segmentation in marketing. If a company has a database of customer information, an unsupervised learning algorithm could group customers based on similar purchasing behavior, even if the groups are not predefined.
Great example, Ethan. And finally, we have reinforcement learning. This is a bit different from the other two types. In reinforcement learning, the machine learns by trial and error, just like how we learn some things through experience. It interacts with an environment, takes actions, and gets feedback in the form of rewards or penalties. Over time, it learns which actions lead to the most rewards. A classic example is training an AI to play a video game. The AI starts with no knowledge and gets feedback after each move. It learns to make better decisions to maximize its score or win the game.
Exactly. And reinforcement learning is especially powerful in situations where there's a sequence of decisions to be made, like in robotics or autonomous driving. So, to recap, supervised learning works with labeled data to predict outcomes, unsupervised learning finds patterns in unlabeled data, and reinforcement learning uses trial and error to maximize rewards. Each of these types has its own strengths and applications, depending on the problem at hand.
All right, let's dive into how machine learning actually works. To train a machine learning model, there are a few important steps involved. data collection, training, and evaluation. Let's break them down, one by one. First, we start with data collection. Data is the foundation of machine learning, because it's what the model learns from. Imagine you want to teach a model to recognize pictures of cats and dogs. You would need a large collection of images of cats and dogs, which are labeled appropriately, cat or dog. The more data you have, the better the model can learn to distinguish between the two. Data could be anything: images, text, numbers, or even sensor readings from devices. Once we have the data, we move on to training the model. This is the process where the model starts learning from the data. It's like teaching someone how to recognize something by showing them many examples. In machine learning, we show the model lots of examples of the data along with the correct answer. The model tries to find patterns in the data that relate the inputs to the correct outputs. For instance, it might learn that pictures with certain shapes and features belong to cats, while others belong to dogs. Finally, we have evaluation. After training the model, we need to see how well it's doing. This is where we test the model with new, unseen data to check its accuracy. Does it correctly identify whether a new picture is a cat or dog? Evaluation helps us determine if the model is working as expected, or if we need to tweak it.
Now, let's break down some key terms that come up during this process. First, data. Data is just the information we give to the machine so it can learn. Imagine data as a pile of puzzles, and each puzzle piece represents a piece of information, like an image or a number. The more puzzles we give the machine, the more it can understand. Next, there's training. This is the process of teaching the machine to recognize patterns. Think of it like learning to ride a bike. At first, you're shaky and unsure, but as you practice and get feedback, you start to figure out how to balance. Training the machine works the same way. It gets better over time as it sees more examples. Finally, let's talk about model accuracy. Accuracy refers to how good the model is at making correct predictions. If the model identifies 90 out of 100 new images correctly as either a cat or dog, we say it has 90% accuracy. It's like grading a test. If you get 9 out of 10 questions right, your accuracy is 90%. But we also need to be careful because sometimes accuracy isn't the full picture. For example, a model might be really good at recognizing dogs but miss a lot of cats. So, accuracy is just one measure, but it's an important one. To sum it up, machine learning works by collecting data, training a model on that data, and then evaluating how well the model performs. The better the data, the better the model can learn, and the more accurate its predictions will be.
Now that we understand how machine learning works, let's take a look at some real-world applications where machine learning is making a big impact. One of the most common uses of machine learning is in recommendation systems. You know when you finish watching a movie on Netflix or YouTube, and it suggests something else that you might like? That's all powered by machine learning. These systems analyze your viewing habits and learn from the preferences of millions of other users to predict what you'll enjoy next. The more data it gets, the better it becomes at making accurate recommendations, and that's why those suggestions seem so spot on. Another area where machine learning is having a huge effect is in healthcare. Machine learning algorithms are being used to analyze medical data, like medical images or patient records, to help doctors diagnose diseases more accurately and faster. For example, AI-powered systems can now detect certain types of cancers in images, like X-rays or MRIs, at early stages, which can save lives. Additionally, machine learning can predict patient outcomes, recommend treatments, and even personalize medicine based on a patient's genetic information.
Great examples, James. Now let's look at how machine learning impacts the everyday technology we use. Take virtual assistants, for instance. Whether it's Siri, Alexa, or Google Assistant, these tools rely heavily on machine learning to understand speech, process commands, and provide useful responses. The more you use your virtual assistant, the better it gets at understanding your voice and preferences. It's learning over time to make your interactions more efficient and accurate. Another great example is image recognition. Whether you're tagging friends on Facebook or using a photo app to find pictures of a specific object, machine learning is at work. It's analyzing images, identifying faces, objects, and even emotions, making it possible to organize and search through your photo library in a way that was impossible a few years ago. These systems learn from vast amounts of data, allowing them to improve at recognizing patterns and making sense of the images you upload.
So, as we can see, machine learning is everywhere around us, from the recommendations we get online to how we interact with our devices, and even in life-saving medical applications. It's transforming our daily lives in ways that many of us might not even realize. While machine learning has come a long way, there are still several challenges that we need to address. One of the biggest challenges is data. For machine learning models to work effectively, they need large amounts of high-quality data. However, not all data is perfect. Sometimes the data we use can be biased, meaning it doesn't represent all groups or situations fairly. For example, if a facial recognition system is trained mostly on images of light-skinned people, it might struggle to accurately recognize people with darker skin tones. This bias can lead to unfair outcomes, which is why it's critical to ensure that the data used to train machine learning models is diverse and representative of different populations. Another issue is insufficient data. If there isn't enough data for a model to learn from, its predictions will be less accurate. Imagine trying to teach a dog to fetch a ball with only a few examples. It's much harder than if you had hundreds of examples of the dog successfully fetching. The same applies to machine learning. The more data it gets, the better it can learn and generalize.
Exactly, James. Now, let's talk about some of the limitations machine learning faces. One big challenge is the computational requirements. Training a complex machine learning model, especially deep learning models, requires a lot of computational power. Think powerful processors, huge amounts of memory, and storage. This can make it expensive to develop and deploy advanced models, limiting access to only those with the resources to invest in such infrastructure. There are also ethical concerns we need to consider. As machine learning becomes more integrated into critical systems like healthcare, law enforcement, and finance, questions arise about how decisions are made. Who is responsible if a machine learning model makes a mistake? How do we ensure that these models are used fairly and transparently? These are important issues that need to be addressed as machine learning continues to evolve and impact our lives.
So, while machine learning has huge potential, it's essential that we address these challenges and limitations to ensure that it's used responsibly and effectively. As we look to the future, machine learning is only going to continue growing and evolving. We're likely to see even more advanced models and algorithms that can solve problems we haven't even thought of yet. One exciting direction is the integration of machine learning with other technologies, like quantum computing, which could exponentially speed up data processing and enhance machine learning models. We're also seeing an increased focus on making machine learning more efficient and accessible, so that even smaller organizations can leverage it to improve their operations.
Exactly, James. Some emerging areas where machine learning is poised to have a major impact include personalized medicine and predictive analytics. In healthcare, for example, machine learning could enable treatments that are tailored specifically to an individual's genetic makeup, significantly improving treatment outcomes. In predictive analytics, machine learning will help businesses and organizations predict future trends, behaviors, and outcomes more accurately, leading to smarter decision-making and more efficient operations.
The future is definitely exciting for machine learning, and we can expect it to transform many industries and our daily lives in ways we can't yet fully imagine. All right, that brings us to the end of today's episode on how machine learning works, basics you need to know. We've covered a lot today, from understanding what machine learning is to exploring its types and practical applications. We also touched on some of the challenges and limitations that come with this technology, as well as the exciting future it holds. Thank you, Ethan, for being such an insightful co-host and helping us break all of this down.
Thanks, James. It's been a pleasure discussing machine learning with you and our listeners.
Before we wrap up, if you enjoyed this episode, don't forget to like, share, and subscribe to the AI Learning Podcast for more insightful episodes. We'll continue exploring the fascinating world of AI and machine learning, so stay tuned for more. Until next time, take care and keep learning.